There are lots of decision-making scenarios that require more than two pathways to take. Like for our self-driving car, what if the traffic light it sees is yellow? We might want to tell the car to perform some other action, like slow down. But right now we only have the options to stop or to drive. So how can we build off our if-else statement to include more than these two options? Well, that's where the else-if comes in. The else-if comes after an if, but before an else statement. And it checks a different test condition than the one in our if. So instead of checking if the light is green, our else-if can check if the light is yellow. And it provides another decision pathway, which is just an alternate set of instructions, like slow down. And this will only execute if our previous if test condition is false. So when isLightGreen is false, our code will go to our else if. And if its test condition isLightYellow is true, then we can print out slow down. And slow down becomes another decision pathway. So only if both of these light conditions are false will our code go to our else and print out stop. Let's see what this looks like in our self-driving car Java code. Here's our code with our else if. The first thing we need to know for our else if test condition is if the traffic light is yellow. So let's say we have a new Boolean variable, isLightYellow, which will be either true or false. And then we have our else if, after our if but before our else statement, and this checks the test condition isLightYellow. So if the light is yellow but not green, we'll enter our else if and print out slow down. And now we have three decision pathways we can take. 1. If the light is green, this prints drive. 2. Otherwise, if the light is not green but it is yellow, this will print out slow down. And 3. If none of those conditions are met, this prints out stop. So let's try this out. First, let's consider what happens if isLightGreen is true and isLightYellow is false. And in this case, the value of isLightYellow won't matter, and we'll see why that is in a moment. Now that we have these Boolean values, the computer will go through our decision-making code line by line. It first gets to our if statement and checks whether isLightGreen is true. It is true, so we'll enter our if block of code and print out drive. And this will complete our code. That's all that will be printed. Our else if and else statements will be skipped entirely. The value of isLightYellow will never even be tested. And that's because once the computer executes an if block of code, like it did when it printed out drive, it will skip down to the very end curly brace of our last else or else if. And for this code, that's at the very end of our program. Now what if we switch these Boolean values, so isLightGreen is false and isLightYellow is true? The computer will start again reading code from the top and first read our if statement. It checks the test condition whether isLightGreen is true, and this time it isn't. So it will move on down to our next block, our else if. And our else if checks if isLightYellow is true. It is, so we'll enter our else if block of code and print out slow down. Our else statement will be skipped again, just like in the last example. And that's because once the computer executes an else if block of code, it will again skip down to the end curly brace of the last else or else if. That means that for even longer series of checks, with multiple else if statements, only one of their enclosed blocks of code can be executed at a time. The block that belongs to whichever test condition is met first. Only if both of these light conditions are false will our computer reach our else statement and print out stop. So if isLightGreen is false and isLightYellow is false, that's the only time that we reach our else statement. Let's see some more examples of how to use else ifs for decision making.